Okay, today I'm going to do a few problems on statistical quality control. In my last class, I discussed about the theories of why these control charts are needed. But in the third session, I can recall that I wanted to write the control limits accordingly as it is given in the book as a theorem, but I couldn't do so because I had some network issues in the third session. So I'm going to write the result or theorem, you can say, or definition from the book which I shared, the note which I shared with you, so that it always remains in front of you, and that will help you to solve the problems. So my X bar chart goes like this. The center line and upper and lower control limits, and upper and lower control limits for an X bar control chart, are, let me write the formula. UCL is equal to X bar plus A2 R bar. CL becomes X bar, LCL becomes X bar minus A2 R bar. And the corresponding R chart is represented as follows. The center line and upper and lower control limits for an R chart are UCL is equal to D4 R bar, CL is equal to R bar, and LCL is equal to D3 R bar, where A2 is tabulated for various sample sizes and D4, D3 are also tabulated from SQC chart for different sample sizes. R bar is the average range and X bar is the average of averages. So these are the two results which are very important in statistical quality control and First of all, we are going to apply these two results in the problems. So if you have completed writing this in your copy, you can write in the chat box, and then I'm going to go to the next page to show you the problem. The problem where you are going to apply these results, and also you are going to draw, if you have scale and pencil and eraser with you, roughly you can draw the charts over there. So I'm waiting for your reply. So once you are done, you can tell me. So my first question of today's class is as follows. The copper content of a plating bath, okay, is measured 3 times per day. 3 times per day. Okay. And the results are reported, in ppm. ppm is the unit. I'm less interested about this units because I'm doing the statistical quality control. So here the limits are not important for me. The units are not important for me. Sorry, units are not important for me. The X bar and R bar values for 25 days are shown in the following table. Okay. Now here below a table is given. I'm going to show you the table, but first of all, let me put the question. Otherwise, if I write all the values of the table right now, if I keep on writing, so one class will be just gone in writing question. So the main question is, using all the data above, find trial control limits for X bar and R charts, construct the chart and plot the data. Okay. Is the process in statistical quality control? Is the process in statistical quality control? Okay, this is the question. And number B, if necessary, revise control limits computed in part A, assuming that any samples that fall outside the control limits can be eliminated. Most of the questions in the book are like that. So I have taken one sample arbitrarily. If you can understand this particular problem, I hope that you will be able to do other problems. Yet, anyways, we should do the problem. So therefore, first of all, you copy the question and don't think much about the table, because I'm going to show you the table very soon. I have 4 students with me right now: Bijita, Bonni, Moshumi, Tushar. Okay. So once you are done with copying these questions, again, you can write me in the chat box. Then I'm going to stop the share of this particular screen and I'm going to show you something else. Okay, Moshumi and Bonni has replied that they have already written the question, and Bijita has also done so. I hope that Tushar is also done with this copying. So I'm going to stop the share, and I'm telling all the students participating in today's class is that don't you feel comfortable, because of this class is mathematics class, because the question which is there in front of you, most of the times we are going to deal with this kind of problems if you are working in a company. If you wish to become a teacher, then probably you will not have to teach these things to your students, because you will not be teacher of mathematics or statistics. But if you are working, if you go on to work in a company somewhere, then you have to deal with the statistical quality control limits. And even if you are not supposed to do the calculations by yourself, but if the statistical quality control manager of your company discusses things with you regarding statistical quality control of your products, then if you do not understand this concept, you shall not be able to participate in the discussion. So to participate in the discussion, we have to have some kind of idea about these things. So therefore, I think this is important for you. Okay. So I'm going to stop the share. And here is an Excel sheet, which I'm sharing with you. All of you can see the Excel sheet. All of you can see the Excel sheet. If yes, then you can write in the chat box. I have shared an Excel sheet. Can you see it? Okay. So this Excel sheet is the table which I was talking about, and which is given in the book. So if you are using your desktop, you can write the Excel sheet. I mean the values over there. If not, then okay, you can write it in your copy quickly. And let me explain something to you. I have, to save time, I have actually copied these particular values in the Excel sheet, because in Excel also statistical quality control can be done. Okay. So let's see whether I can do it or not. I mean, some calculations can be done with the help of Excel sheet, and that will save our time. Now, these are the values you see. First of all, we shall have to understand what are these values are. You look at the day counts. It starts from 1 to up to 24. So for 24 days, they have for 25 days actually. See, there is another day below. If I scroll a bit, yeah, 1 to up to 25. So as it is given in the question, this X bar and R value of 25 days are shown in the following table. So all these values are actually X bar values. X bar means in the day one, a few items were chosen. Okay, the total number of items was not 25. The total number of items maybe was 5 or 4 or 10, whatever. And for those items, the mean of the thing has been calculated. The copper content of a plating bath. It has been measured 3 times a day. So for 3 values, consecutive 3 values, average has been taken. That means the values were added and was divided by 3. That value is 5.55. 5.5. For day 2, the value was for day 2 the 3 values consecutively were chosen, and the arithmetic mean was calculated, and that is 5.39. In this way, all the means have been calculated, and all the ranges have been calculated. So the calculation of mean and range have already been shown to you. You know the definition of mean and range. So I'm not going to explain this thing to you right now. Now you have the formula in front of you. So as per the formula, I am going to calculate. I need the center line that is denoted by X bar, and I need the upper control limit and lower control limit. And so I'm going to calculate these things over here. Okay, so X bar, in the formula you have written X bar bar, the mean of the means. So I'm going to calculate this from here. Okay. So what we do is that we first of all select this particular value, and then just a minute. I'm going to select this particular value, particular column, and one column extra below, which is blank, where the calculation will be done. Okay. Then I'm double clicking to the cell and putting equality sign over there. Then I'm going to take my cursor to the formula section, where you can see that there is a section called math more functions. In the more functions, you will be able to see the function which is called statistical. And here you see one option is there which is called average. So I'm going to click on it. Okay, average has been see, since I am interested about column B, and column B, the first value is for the cell B2. So B2 has been selected over here, and the last cell is B26. I mean, they are not taking my 25, they are taking their cell number. So that is B26. You do not put 25 over here, because that 25 is actually my writing, because my number, because one of the cells is actually been taken by the heading. So therefore you have to be very, very careful about it. And see, the formula has already been chosen over here. Once I click on the formula that has been written over here, and box is open. So I actually want the arithmetic mean of the value starting from B2 to B26. And you see the value is being shown over here, 6.292, 2912. You can't understand how to calculate average by that. What do you mean? You can't understand how to calculate average by manually or by this Excel sheet? What do you want to know from me? What do you want to know from me? Okay, unmute yourself and then you can say me. You can unmute yourself and then can say. Yeah, in the last column, I have written the average. Actually, see, You want to know about the Excel calculation, or you are asking me the formula for arithmetic mean? First of all, I have to understand that. If I ask you, if I ask you to calculate the arithmetic mean of this column, if I ask you to calculate the arithmetic mean of X bar column, what will you do? You can unmute yourself. I have activated that. If I ask you to calculate, yeah, tell me. I'm asking you, if I ask you to calculate the mean, I mean the mean of this column X bar, then what will you do? Manually, what will you do? You will add all the figures together and you will divide it by how many, what number? By 25. 25. Okay. Then that is the thing which I'm doing by Excel to just save time. So if I want to calculate the, if I want to add the numbers starting from this cell and ending to that cell. Okay. But where do you want to put your values? I mean, which particular cell the value will be shown. So I have selected one extra cell below. So that is my result cell. And there I am double clicking and putting equality sign. After that, I'm choosing from formulas, I'm choosing more functions, and from more functions, statistical. After clicking statistical, this box is coming. This box is coming, and you see already the thing has been calculated. The average has been calculated, 6.2912. So I'm clicking on it. Okay. And the value you see 6.292 is getting reflected in the cell selected. Have you understood, Bonnie? And if you want to calculate the R bar, I mean arithmetic mean. So again, I'm going to show you this thing. I am selecting this cell and I'm pressing my mouse. I'm pulling it downwards. Sorry. I have to do it since I'm using my laptop. So actually, yeah, pulling it downwards. And if I select up to this, where will I write my answer? So I'm selecting one extra cell below. And then in the blank cell below, I am double clicking the cell, putting equality sign. And then I'm going to formula section where I'm choosing more functions, and statistical and average is being selected. Then you see, I'm actually considering the cell C2 to C26. This is the formula, C2 to C26. And the average is 1.1328. So I am clicking on it, and that result is being reflected in this cell, you see. Okay. Now, because there are so many results, so many values, 25 values, I could have asked you to do it by your calculator. So just to save time, because you're already late because of the previous class. So I actually saved your time, and I'm showing you that by using the Excel, you can also calculate the arithmetic means. So the X bar, this chart's arithmetic mean is 6.2912. And the second chart, that is R, its arithmetic mean is 1.1328. I shall send you the image, the image of the question to our WhatsApp group. So you can copy the question, you can copy the table from there. Right now, you just write these values in the chart. I mean, in your copy. I shall be using those values in the. I shall be using those values in the in my whiteboard where I was actually doing the calculations. So I am writing it in the chat box so that you shouldn't miss it. Sorry, just a minute. The average of averages, that is X bar is equal to 6.2912 and R bar is 1.1328. This which I have calculated right now using the Excel. So you cannot plot the statistical quality control chart in Excel. It's not, the provision is not there. For this, other statistical softwares are available, but which right now that provision, that is not here with me. That can not be done in this class because I do not have access to those softwares. So I'm going back to my original whiteboard where I'm going to write my answers which I have got. Okay. So I'm stopping this share, and that was my question. This was my question which I wrote, and I'm going to the next page, and the solution, I mean the values which I've got are like this. The value of X bar is actually the summation of Xi bar divided by N. And that value has come out to be 6.2912. 6.2912. The value of R bar, which is summation Ri is divided by N, that has come out to be 1.1328. 1.1328. Okay, so we have got this is actually our center line. This is actually our center line for X bar chart. And that is our center line for R bar chart. The two center lines have been obtained. Now UCL for X bar chart, the UCL is given to be X bar. What was the formula? A2 into R bar, okay, plus A2 into R bar. So here you can put your values. X bar, that means you put 6.2912 plus A2 into R bar means 1.1328. And LCL is given to be X bar plus minus A2 R bar, which is 6.2912 minus A2 into 1.1328. Okay, so we are going to calculate that for X bar chart. And for R chart, the UCL formula is D4 into R bar and D3 into R bar. Okay, so the formula is D4 into R bar. It is the formula for UCL. So D4 will be multiplied by 1.1328, and LCL, the formula is D3 R bar, which will be multiplied, actually D3 will be multiplied by 1.1328. Okay, now we are going to go to the statistical table which I shared with you in the note. If you have the note, you have the table with you, and I'm looking for the values from my book. the table given in my book. So in the from the table for n is equal to, our sample size is how much? 25. For n equals to 25, okay, my value of A2 is 0.153. You can also see it from your table if you have this table with you right now. And D2, I mean this is for X bar, okay, and for R bar, for R bar, not R bar, I must write R chart. The value of D3 is for n equals to 25. The value of D3 is 0.459, and the value of D4 is 1.541. So we are going to substitute these values over here. So we write 6.2912 plus 0.153 into 1.1328 and 6.2912 minus 0.153 into 1.1328. Here I'm going to write 1.541 because this is the value of D4. That would be multiplied by 1.1328, and here 0.459 will be multiplied by 1.1328. Okay, so let's calculate the values. You also calculate the values by yourself so that we can together check it. So let me calculate it. The first value which I have got, is like this. It is 6.4645, and this value is 6.1178. Okay, quickly copy these values. I have some reason for telling you so. And I'm going to now calculate UCL for R chart. So that would be 1.541 multiplied by 1.1328. This comes out to be 1.7456, and 0.459 into 1.1328, that comes out to be 0.5199. Okay, so these are the values which I've calculated. So we have got X bar value as center line as this, and its corresponding upper limit is 6.4645, and LCL is 6.1178, and the R bar is given as this 1.1328. Its corresponding UCL is 1.7456, and its LCL is 0.5199. So what you are going to do, since this class is going to end very soon because of the time limits, what you are going to do in your copy, you are going to write, you're going to draw the statistical quality control diagram over there. Okay, so let me quickly copy the value. 6.2912 is the X bar value. UCL is 6.4645. LCL is 6.1178. And R is given to be, R bar is given to be 1.1328. UCL is 1.7456. LCL is 0.5199. Okay, so you are going to plot this table. This you are going to use these results to draw your statistical quality control chart. So we'll continue our discussion regarding this matter in the next sessions. In the next session, this session is going to end. Let us wait for this to end automatically, and then in the next session you again join, where I am going to continue with our discussion of UCL and LCL for X bar and R chart.